So anyways, hi everyone. So I'm Jeremy. I'm at Concordia, a professor. We have a research program, master's research program that specializes in security. Number of former students in the room, which is always good to see. So I won't bore you with my CV. I'll just say that I've worked on blockchain technology, which comes from Bitcoin almost immediately after Bitcoin came out, so for quite a while. Okay, so why are we here? Why is there a talk on blockchain at all? Well, blockchain is very popular. Maybe 6 months ago it was even more popular than it is today, but it's still going strong. You can walk down to chapters and buy a book about blockchain. You can watch TED Talks. You can read about it in the New York Times. Lots of companies are interested in blockchain technology. This is just one example of a project called the Hyperledger project, which was started by IBM and then passed over to the Linux Foundation. So you can see lots of companies, including companies that are represented here, and they don't even all fit on one page. So here's the second page of companies that are just on this one project, this one consortium. Okay, so I wasn't sure, I know a lot of you're obviously here because you're in security, but security now is so broad, you might do incident response or malware analysis or that type of thing. So I wasn't sure the sort of technical level. So I went with the kind of executive level talk. So most people don't complain if the talk is too simple. It's usually when it's too complicated. So let me give you the kind of pitch of what blockchain is, why people are excited about it from my perspective. So the way I see blockchain technology is it's kind of an extension of what you might call the digital revolution, which is digitizing different information. So I don't have to sell you on why digitization was good. Okay, digitization made accessing data a lot easier, more efficient. There's a lot of cost savings associated with it. Now I want you to think of an industry that's still based on paper. So the industry I'm going to think of, which is actually still based on paper today, is supply chain management. So supply chain management, especially the transport industry, it still revolves around a lot of paperwork. So let's say that, for example, just as a motivation, let's say there's coffee and it's coming from wherever, let's say Colombia or Costa Rica, and it's going to make its way to Montreal. What's going to happen is it's going to land, say, in New Orleans. There's a port authority there. They're going to fill out some paperwork. It's going to transgress the US border, so there's going to be some border paperwork. Then it's going to go on a rail, say CN brings it up to Chicago and then across the border. Each of these times it generates a new sort of paper stream. Eventually it ends up in Montreal. Okay? And so what I'm told, so this is one industry that's interested in blockchain technology. And what I'm told is that by the time it reaches here, you could have hundreds of pages of different forms that have been filled out. Okay? And so we might think about how could we do this better? And your first idea is, well, let's digitize it. Right? Let's just make all these forms digital. Then it's really good. Okay? We'll throw them in a database. Everyone writes the forms into the database. Then we're not going to maybe lose forms, or let's say you're trying to find the 50th form in that stack of 200 forms. You can jump right to the 50th one, right? If it's not there, then you can at least track down who didn't write it, who was supposed to, and you can try and figure out where it got lost. Okay, so digitization is going to give you lots and lots of efficiencies. Now, there's one problem with this model. The problem with this model is, who is it that's going to run this database? Who's the person that's going to put this database up? Okay? So what we have is we have a scenario where there's a bunch of people. They're all standing around. Some of them are writing to the database. Lots of people are just reading from this database. Okay? And the person that owns it is really in a position of power here. Okay, so let's take that supply chain example. Who's going to run the database? It could be the US government because it went through the US border. It could be the Canadian government. Maybe the US and Canada are going to fight over who's the one that's going to own this database, right? Maybe it's CN, they were the rail lines. Maybe it's the port authorities, right? There's no logical player that's going to hold this data, okay? And when you hold data, you have to understand that that's sort of a privileged position, okay? You get to control who has access to your data. Tomorrow, if you don't like some entity, some counterparty, you can cut them off from the database. And if all the information goes through your database, then you basically cut them out of the market. I'll give you an example of that that's not related to this or blockchain, but if you bought or sold a home in the last couple of years, you probably use something like MLS, or in Quebec we have a different one, Centris. And so they always change the rules about that, right? So it used to be that you had to be a licensed real estate agent to list your home. Then for a fee, anybody could do it. And the real estate agents hated when they switched to the fee-based model, and everyone else hated it before it was the real estate model. And because you have this company that's holding this database, right, they have the power to just change the rules, and that can sort of disrupt the market, okay? Then there's some logistical challenges. If you have a database, you have to make sure it's available 24/7, it's redundant, it never goes down, that type of thing, okay? So what is blockchain aiming to do? What blockchain is aiming to do is it's trying to solve this problem of who owns the database. So what we're going to do with a blockchain is, let me mention one other point I forgot. Another really important point, that's why it gets its own slide, is when you have a database, you end up in this situation where you have 2 copies of your data. So you have your local data, and then you have the data that's in the database. And you have to make sure that they match. That's called reconciliation. So for example, let's take another example. Let's take banks. So let's say a bank is sending money to another bank. What they'll do is they'll report it to a database. The database is held by Payments Canada. Then at the end of the day, Payments Canada is going to announce that the net movement from, say, BMO to RBC was such and such, $10 million or whatever the case may be. Then they have to go through all their local records and make sure those numbers add up. Okay, so they spend a lot of time with reconciliation. So this is one project actually where a blockchain was piloted to try and solve this problem. Okay, so what we're going to do is we're going to take this database. We're going to take all the transactions that are on the database, and we're going to give it to the participants themselves. So all the people who are reading and writing to this database, they're going to hold the data instead of it being held in a central database. Then we can get rid of the central database. We don't need it anymore. But what we need instead is we need some sort of synchronization protocol. We have to make sure that whatever data you're holding, because you're holding it, it gets reflected around the network. And so everybody ends up holding an identical copy of the same transactions. If you can basically guarantee this, then you can not have a database anymore. You can get rid of your database. So that's what blockchain technology essentially is. It's that kind of synchronization protocol, or the consensus protocol, where you can hold some data and you can be assured of a lot of natural properties that you might want. So one property is that once you write something to your ledger and it's accepted by all the other people that are on this network, it can't be overwritten. Okay, you can't change it, or at least it's really hard computationally to overwrite it. Another thing that there's this sort of misconception that blockchain will eliminate trust so that any data that's written is true. Okay, so the blockchain will make sure that what you're writing is true, and then it will get rid of it if it's not true, or it won't let you write it. So this is a misconception. Blockchain can't do that. It doesn't know what's true. Like if you write some contract where I'm going to pay Douglas, $100 if Trump wins the election, and if Clinton wins the election, I'm going to get the $100. We have this sort of bet. The blockchain doesn't know, or these networks, they don't know whether Trump wins or not. Okay, so that's something that they can't decide. What you can do is you can write some ideas of truth where you define what truth means in a machine-readable format. So anyway, this is going a bit under the cover, so we'll just kind of skip over that thing. But I just want to emphasize that blockchains don't get rid of all forms of trust. They get rid of some forms of trust. Another thing is that everyone sees the same data. Okay, so if you're looking at your copy of the blockchain, you can be assured that everyone else is looking at the same copy. You can be assured that you don't have one book of transactions that you're opening up to investors, and you have a different set of books that you're opening up to auditors or the tax agency or something like that. So that's a really fancy property we call equivocation, but basically once you show the data, you're showing that same data to everyone. The other thing is you have a local copy. You can be guaranteed that your local copy is reflected in the copy that everybody has. And this is really nice because let's say you go offline or you lose your local data, no problem. You can just grab it from someone else that's on the network. So there's built-in redundancy. Nodes can go offline, that type of thing. There can even be malicious actors trying to disrupt the internet or trying to disrupt this particular network. And you can maintain security properties in the face of a lot of these threats. Once again, there's some assumptions that underpin this, but I'm sort of glossing those over. Okay, now the final thing is we've only talked about blockchain as kind of a passive data store. right? So you have some data, you're going to store it, that's fine. Blockchains work well in that case, but it's not really that exciting. What people are most excited about is that not only can it store data, it can actually run code on that data. So if the data comes in, you can define code that should be run, or a process that should be run, or an algorithm, however you want to think of it, when that data comes in. And just like the data itself, you have all the same properties that apply to that process. So essentially what happens is every node that's on the network reruns that process for themselves. They all agree that the output of that process is whatever is being written into the blockchain, and they don't let it get written into the blockchain unless if they all agree on it. Okay? And so when you see it and you see that it's in the blockchain and it has been written to the blockchain, you don't even have to verify it yourself. Just by virtue of it being in the blockchain, you know that all the nodes on the network agreed that this was actually the output of this particular process on this particular data. Okay, so that's what actually unlocks a lot of the potential of blockchain. So it's no longer just a database that happens to be super redundant. It's actually more like a computer, like a trusted computer that you can use. So here's a bunch of use cases that people have proposed. Some of these are reasonable and sensible. Some of them are a bit of a stretch, but this is the type of thing that you hear about in industry. And what I want to emphasize is not that any one of these use cases is particularly good. The really sort of thing that people get excited about for blockchain technology is, what if you have a bunch of these use cases on the same blockchain? So take, for example, land deeds. Let's say land deeds are on your blockchain. So now you are registering land. Well, let's say you want to sell that land. You're going to sell it for a payment. Well, that payment could be on the same blockchain. The owner of the land, both the buyer and the seller, they have some identity, right? What's a digital identity look like? Well, maybe the digital identity is also on the blockchain. Then maybe the buyer wants to go and take some insurance or something like that, and they want to prove that they actually own it. Well, maybe the insurance is issued on the exact same blockchain as well. So the idea is that once you kind of get all of these things, so you might say land deeds, whether it's paper, database, blockchain, doesn't really matter. Like there's no big reason to have it on a blockchain as opposed to in a database, right? But the idea is that if you have all of these things on a blockchain, then you can start to see some efficiencies that you might gain by having them all interact with each other. Okay, so for the second part of the talk, I'll just go through, I give this talk a lot, and so there's always certain questions, so I'm going to try and preempt all the questions you have, and then I'll leave the floor open for your actual questions. So first off, people are sometimes confused about the relationship between blockchain and Bitcoin. So blockchain is a technology that came out of Bitcoin. So Bitcoin is a currency, a digital currency. It's its own currency. It's not like an electronic form of Canadian dollars. It's its own currency. And it was, developed, and underlying it or buried inside of it was this blockchain protocol. Okay, and so a lot of people looked at Bitcoin. They said that's interesting currency. That's kind of cool that you can do digital currency. But what we really like is this technology that they're using underneath it, and we see all sorts of use cases for this technology beyond digital currency. The term blockchain, different people use it different ways. So some people are especially if you go to like an actual blockchain conference, people are very religious about blockchain being Bitcoin specific blockchain. So if you try and use that term for anything else, then you'll get sort of shouted down. Other people have a more general view. So any kind of technology that tries to implement a sort of what we might call a distributed ledger, then that's blockchain. And then if you go into like the banks and things like that, some people just use blockchain as kind of a word to describe the digitization or the dematerialization of different things that were traditionally paper-based. So once you go in and you digitize it, it's just blockchain, whether there's actually a blockchain there or not. So my point isn't to sell you on using the term in one particular way, but I'll just say that if you get into a discussion with someone else and there's some disagreement there, it might be just that you're using the term differently. Okay, so a blockchain, I originally kind of pitched it as a sort of database. So what are the differences between databases and blockchains? So from my perspective, I actually see blockchain as a subset of databases. I'm happy to call it a database. But for me, the emphasis is really on different things. So there's a lot of people in academia in my university that work on databases. And when they work on databases, this is my vision of what they're doing. They have large data, huge data. They're trying to organize that data so that you can do really complicated queries and it's going to respond really quickly to those complicated queries. Okay, that's my view of databases. Blockchain, by contrast, is for small data, really small data. So Bitcoin's blockchain, you can add 1 megabyte every 10 minutes. So that's not a lot. An MP3 file is, 5 megabytes. It would take you an hour to put an MP3 file on Bitcoin's blockchain. And that's if you could monopolize the entire blockchain for your purpose. Okay, so this is tiny, tiny data. There's no queries. Basically, you have one query when you see a blockchain, which is give me everything. So when you install Bitcoin for the first time, you spend 2 days downloading the entire blockchain that has every transaction since it launched. So there's no sort of complicated queries. So this sounds awful, right? This sounds like a horrible database. Why is everyone so excited about this horrible database that's really slow and is for really small data? Well, it's because of the security properties. Okay, so everything that's written, every process that's run is validated. It's validated by all the nodes on the network. So it's just a different emphasis. So it's for small data, but really important data. That data where security is more important than efficiency, that's when you could use a blockchain. They're also secure against malicious nodes. So there's this network, and you can actually tolerate a large number of malicious nodes on your network before you start breaking different security properties. What's the sort of state of, is blockchain legal? Are people using it? Is it standardized? So there is a standards committee that's looking at blockchain. So it's an ISO committee, and then it's reflected in the Canadian standards. So the Standards Council of Canada. And then a bunch of industries will sometimes come together. They form a consortium, and then they'll try and work out some different standards for their particular industry. So for example, transport industry has a transport alliance. So they're working on standards. The banking sector has come together under a project called R3. That's a different consortium. In terms of regulation, most of the regulations around Bitcoin per se, not around blockchain more generally. So from CRA, we have guidelines on how you should file your taxes if you make a lot of money investing in Bitcoin. If you're going to go out and get a financial audit, maybe you're going to go to AMF and you're going to try and register your business, you might need a financial audit. And so the auditors are going to look at the Bitcoin that you hold or the different assets that you hold, and they have to try and categorize it using their standards like the IFRS. And so that becomes a little problematic, but there are guidelines for it that nobody's really happy with, but everyone's moving forward with. If you go to an exchange, you have Canadian dollars, you want to turn it into Bitcoin, FinTrack is in charge of making sure that you're not going to use that to finance terrorism, you're not going to use it for money laundering. They have some regulation that's been proposed that's open for comment, but not yet enforceable on how exchanges should operate. So that one's sort of in flux. And then if you want to issue, you might have heard of these ICOs. It's sort of an excitement within the blockchain industry for raising capital. If you want to do that properly and legally, you should be going through the AMF, and they have a whole process for handling that. Another thing is that, so people think about, Bitcoin as being anonymous or confidential or private. And so there's a lot of misconceptions around what exactly that means in the case of Bitcoin and then blockchain more broadly. So by default, out of the box, if you implement a blockchain, there's no confidentiality. Okay, so everything is public. So in Bitcoin's case, you can see every transaction. Okay, you can go back to the start of Bitcoin, and every transaction sitting there, you see the accounts that spent it, the accounts that received it, and the amounts themselves. You can add confidentiality on top, but that's a new layer. Okay, so blockchain isn't giving you that. You have to use encryption technology, then you have to worry about key management. It gets kind of complicated quickly, but there are people that are interested in it. The other thing is, what about where the money's coming from or where these blockchain transactions are coming from? So in Bitcoin's case, what happens is transactions originate from keys. So keys you can think of as kind of like a serial number or an identity, a random number. So they're not coming from Jeremy Clark if I send a Bitcoin transaction. They're coming from some key I control. So that gives you some level of anonymity, but you can still see the money moving around and you can cluster accounts together. I still have to launch that transaction from a computer that has an IP address. So people talk about Bitcoin being anonymous. It's not really truly anonymous. There are some projects on adding even stronger anonymity to Bitcoin, and there's conversely projects on adding stronger identification to blockchain technology as well. So you can do either, but out of the box, you don't get any strong notion of anonymity. Okay, another thing is that people are always curious about, you read in the news about Bitcoin using hydro, right? So there's lots of electricity that's being used by Bitcoin, and it's really wasteful. And so where's that coming from? I mean, we have this database, there's a bunch of sharing of data, like where's all the electricity that's somewhere in the protocol? Okay, so what happens is, as I said, everyone has a copy of the data, and you have to agree on whether that data is correct, or you have to make sure that everyone synchronizes their data across the network. So what you're going to do is someone's going to propose what the data should look like, and then effectively what you will do is you're going to vote. All the nodes are going to cast a vote on whether they agree with that or they disagree with it. If enough of them agree on it, then they all update their ledger, and then you move on to the next process. Okay? Now the question is, how do we actually vote? So one way we might vote is, well, every voting system at its heart has like one vote per something, okay? So what we might want to do is we might want to do one vote per computer, okay? So every computer has one vote. The problem with this is I can make my computer look like 10,000 computers, right? I just get a bunch of IP addresses or whatever the case is. So there's no notion of what a computer is. So there's no way you could actually vote this way unless if you had like kind of a closed list of computers. So some people in industry, they're looking at having like a closed list of participants where RBC has one computer, CIBC has one computer, Desjardins has one computer, whatever. So that's fine. That works. Then you can just vote through traditional methods, use what's called Byzantine fault-tolerant protocols. If you want an open network, if you want to run it on the internet, you can't vote one per computer. Okay, so the sort of insight of Bitcoin is, here's what we're going to do. How do I know that one computer is actually one computer and not 10,000 computers? Or how do I know that those 10,000 computers aren't just one computer? What I'm going to do is I'm going to say, okay, you look like a computer. What I want you to do is I want you to run as fast as you can doing wasteful work, just solving some computational puzzle. You're going to run full tilt as fast as you can, 24/7, solving this. And I have a good sense of how fast a computer runs. Okay? And so you're going to do this process over and over and over again. And then basically, the faster you can do this computation, the more votes you get. So what I'm going to do is I'm going to give you one vote per computational unit of work that you can output. Okay? Now I can't make my one computer look like 10,000 computers because I can't run it 10,000 times as fast. I would have to literally go out and buy 10,000 computers, and now I'm actually legitimately 10,000 computers. Okay? And so that's what these mining operations do. They go out and they buy 10,000 computers, they put them in a warehouse, and then what they're doing is they're voting in this process, which is good for the network because it validates all the transactions, and then they're actually rewarded in Bitcoin's case. So when new currency comes into circulation, it's given to the people doing this work as a form of compensation. So that's sort of how the economics of Bitcoin works. Here's just the one thing I stole from another person's paper. I should put the citation, I didn't do that. But it shows you how expensive Bitcoin actually is. So just look at the top, it's a big slide. But you can see that gold mining, these are based on estimates, but about a year worldwide, it costs about $105 billion. Bitcoin is a fraction of a billion. So it's still nowhere near like the cost of mining gold or things like that. So people are concerned about it. It is a concern about how much power it's used, but you should put it in context as well. Okay, the final sort of FAQ is, where did it come from? Why did we have no digital cash for 20, 30 years? And then all of a sudden Bitcoin came out and, did it just drop out of thin air? And how do we know it's not, totally corrupt because it just came out of nowhere and that type of thing? So I have an article that I wrote with a colleague at Princeton that shows that actually all the ideas that underlie Bitcoin and the blockchain, they're old ideas. They're ideas that go back to the 80s, they go back to the 90s. And the real contribution of Bitcoin wasn't inventing a whole bunch of new things. It was taking about like 5 different kind of contributions and weaving them together in a new novel way. So I don't want to undercut the contribution of Bitcoin itself. It was sort of ingenious the way that the inventor, Satoshi Nakamoto, who's anonymous, kind of weaved these contributions together. So there's a real contribution there, but at the same time, it didn't come out of nowhere. So all the things were kind of lying around, all the components. It was just a matter of assembling them correctly. So if you're interested in history, I would forward you to that record, or to that report. A few other things, since I can't teach you all things blockchain and Bitcoin in half an hour. If you're really interested in this, you want to learn some more, I recommend a course that you can take for free on Coursera, or you can watch it on YouTube. I give one of the lectures. It's from Princeton. It covers mostly Bitcoin, but it also gets a little bit into blockchain applications towards the end. There's a textbook version of it as well. The PDF is free, so you can just go download it. If you want a copy for your desk, you can buy it from Amazon or anywhere that sells textbooks. And then if you're interested in the history of Bitcoin and where the ideas came from, I recommend this article. OK, so that's enough self-promotion. And I'll take lots of questions. We have about 15 minutes, I think, for questions.